In this lesson, we will implement the movement of the player. The player will be bouncing on X and it will be moving downwards in Y. Every time it reaches somewhere near the boundary, it will reverse the velocity and then again. And once it reaches the height of the screen, so when it goes through the full height, when it leaves the screen, then it will be killed so that it can be reused in our yet to create pool of objects. In this lesson, I'll implement the movement logic, all of the bouncing and the killing once it leaves the screen. The first thing we need to do is enable physics in this object, because so far it's just a dummy sprite, it doesn't do any physics. For that, we just type this.game.physics.arcade and we pass the sprite. So now the enemy will have a body, therefore it can have a velocity. We have our update method in game state that is called multiple times per second, and so far we've always used that to check for collisions or for positioning. But our prefabs in Phaser can have their own update method, so we don't have to put that much stuff into the game state update method. When it comes to individual enemies and how they behave, they can have their own update method and pretty much control themselves. So we will add this update method. We need to add it to the prototype. This spacehipster.enemy.prototype, and is just a function. And that function, we will do a check. We will check that x is, if x is smaller than, let's say, 5% of the screen, so somewhere around here, that would be 0.05 times this.game.width.world.width. So if that is true, then we want to, if the enemy moves too much to the left, then we want to push it to the right and change the direction of its velocity. This.x will be then equal to this amount, but we're actually going to give it an extra couple of pixels, otherwise it gets stuck. And this.body.velocity.x times equal -1. That means that we're multiplying it by -1, so we're reversing it. Now the same for else if, but on the other direction. So if it's, in this case, it will be greater than 95% of the screen, and if that's the case, we will push it back a little bit. We will push it again to 95, but just a bit further, and we'll reverse the velocity. Now, as you can see, the game is relative to the size of the screen, but you could easily just have your own minimum or maximum or fixed values for these numbers. So if you, in this case, for example, if I'm playing the game on the landscape mode, which you can change here, let's restart it. If I'm here, you see that the game play is going to be different because they're moving a lot more. So if you do not want that on your game, instead of using a percentage, you can just have your own fixed values. So that's an easy solution for that problem. But in this case, I want to make it so that it's different on each phone, just to show you how you can do it that way. Okay, so in order for us to test this, we actually need to give it a speed, which we haven't done yet. So I'm going to go to game state, and where we create our enemy, I'm just going to give it a speed, enemy.body.velocity.x. Let's give it a speed of 100. We need to set a velocity in x and in y to test all of these things. So we can now, it's not actually moving, can read property velocity of null, velocity, then let's check that when we create this. I think I haven't saved this, that was a problem. So let's see now. Object is not a function. This.game.physics.arcade. Oh yeah, this is not this.game, it's just game, because we're passing it, calling it game in here. So actually, for all of this to work, I need to I need to pass it as game, because then we access that in here as well. So I'm assuming that this.game is around, and I had to save it as game like that. So let's see now. We have an error in line number 8. So that's object in a function, arcade.enable, right? Enable. So now this is actually working, and you can see that it bounces. And the last bit that we have to implement is the killing when it reaches the border of the screen. And by the way, all of these errors, I think it's part of the learning too, because you're going to encounter a lot of errors when you develop. That's just what the way it usually goes. So you will have things like this, and you have to make sure that if you're using game in a method, that you put that game as a property so that you can access it in different methods. Okay, so let's just add the last bit that we need to check, which is that if this .y is greater than this game.world.height, basically if we reach the edge of the screen, if that is true, actually not this .y but this .top. So basically the top of my sprite has reached, which means that the sprite has basically disappeared. Then this .kill, so that will kill the enemy. And if we are working with a pool of objects, that will allow us to reuse that sprite for the next, when it's needed next. So to summarize what I've done, I've implemented the movement by using the update method. Your prefabs can have update methods. They behave just like the main update method of the state. If you pass things like the game, then you can access the world. Anything that you want to access here, you need to have passed it somehow. If you want to check collisions with other elements and that sort of things, you need to have passed them somehow so that they are available for you to use. Don't forget to enable physics and do it properly, not like I did it, every time that you work with velocities or collisions, so that you can actually have the elements behave the way that you want.